DNS Records. In order for a DNS server to be able to resolve a name of a host to an IP address, that DNS server must have a DNS record created for it. In DNS, there are lots of different types of records you can create, although in most cases, you'll be dealing with only the 3 or 4 popular ones, which are an A record, the 4A record, which is the same as an A record, except this is an IPv6 record, whereas the A record is an IPv4 record. We have the CNAME or the alias record and MX records. Now, before we get stuck into talking about the common types of records you'll create on a DNS server, let's start with the SRV records or the service record. Service records are essential to Active Directory as they let DNS know what servers handle particular types of services. In other words, a service record tells DNS that if you're looking for this particular type of server that's responsible for a specific service, then it's over there. Service records let DNS identify servers that run a particular service, such as a global catalog server. It can identify servers that reside in a particular domain, as well as servers that use a particular protocol, such as TCP or UDP. Now, once a service record has been retrieved, it tells DNS the name of the server that meets the criteria of the request. It also tells DNS what port is needed to contact the server, and because service records allow you to specify multiple servers, you can also give servers different priorities. For example, when you attempt to log on to an Active Directory domain, DNS uses the service records to identify which servers are acting as domain controllers, then responds to your request with the appropriate domain controller's details so your client computer can then log on. Now, there are many different types of services that DNS keeps track of, and if you want to know what kind of services are available, if we click on Start and open up Computer, and we'll go to our C drive, followed by the Windows directory, we'll scroll down and find our System32 directory, then we'll go to the Drivers folder, etc, and we'll open up this file here called Services, and since it's really only a text file, we'll open it up with Notepad. And if we expand this file, in here, you're going to see a bunch of commonly used services and also what ports they communicate on. So go and take a closer look at this if you'd like. Okay, so let's take a look at a service record so you can get an idea of exactly what we're talking about. The first part of a service record lists the service for this record. In this case, this record identifies that this server is providing the global catalog service. The service is always prefixed with an underscore and can contain other common services such as LDAP or Kerberos to help DNS locate servers that run these types of services. The next requirement of a service record is to join sections with a period. After all, this is DNS we're talking about, and everything is separated by periods. Then we have the protocol, in this case TCP. So we know so far that to contact the global catalog service, we need to talk to it using the TCP protocol. Then we have the domain name winstructorlab.com, which indicates that this domain is providing the global catalog service. The value of 600 is the time to live for the record. This tells DNS that when you look up this record, you can cache it locally, but you'll only be able to do that for 600 seconds or 10 minutes. After that, you'll have to come back and get it again. We can see that the record class is Internet, and this field will always be Internet using our present version of DNS, but that may change in the future. And we can also see that it's a service record. Now next we have the priority of the record, and this can be a number ranging from 0 to 65,535. Now the lower the number listed here, the higher the priority that's given to a record. So for example, if we had 2 service records pointing to 2 different servers that had the same service running, and one had a priority of 10 and the other had a priority of 100, then the client would be directed to the server in the service record with the value of 10, since 10 is lower than 100. Now if that server was down, then the client would be redirected to the other server with the value of 100. Next we have the wait, and this can be used in addition to the priority field to create a load balancing mechanism. Now, unlike the priority field where if you had 2 servers with different priorities, the one using the highest priority will always be the server used unless it's down, with this wait field, when you use any value other than 0, this will determine the percentage of time that clients should use a particular server. So for example, if we have two service records and one has a weight of 50 and the other has a weight of 100, if we add those two numbers together, we get 150. 50 plus 100 equals 150. So for every 150 queries, one of those servers will be contacted 100 times, the other only 50 times. And this is useful, for example, if you have superior hardware in one server and it can handle a greater load, you might want to adjust the weight so it does more work. Now the range of values you can have here are from 1 to 65,535, but if you don't need to load balance your servers, then you can set this to 0. Now next we have the port that this service will talk on. So for this record, the Global Catalog service talks on port 3268. And finally, we have the name of the server, or the target if you like, that the service is located on. So we know that the domain controller dco1.winstructorlab.com is going to provide our Global Catalog services. So when hosts in our domain here want to contact a Global Catalog server, our DNS server already knows that DCO1 performs that role and provides the Global Catalog service, so it can let our host know that they need to contact DCO1. Now, regardless of whether DNS is actually installed on a domain controller or a member server, a file called netlogon.dns will be stored on the server, and this file contains a list of all of the service records that are required to support the use of Active Directory. So we'll go and click on Start, and we'll open up Computer, and we'll navigate to our C drive, Windows. We'll scroll down and go into our System32 directory, and then the config folder, and we'll open up the netlogon.dns file, which is just simply a text file, so we'll open that with Notepad. And if we expand this in here, you can see a bunch of service records such as LDAP, Kerberos, Global Catalog servers, and so forth. That should now look familiar. So let's go and click on Start. We'll go to Administrative Tools, and we'll launch the DNS console. And we'll expand the console, and we'll come over here, we'll expand our server, DCO1. And if we look under our forward lookup zones, you can see this msdcs.winstructorlab.com folder. And this was new in Windows 2003, and it's been carried over to Windows 2008. And this folder keeps track of all of the domain controllers in your forest, all of the domains, Global Catalog servers, and the server that's holding the PDC emulator role. And this is what's known as an application directory partition, or rather a forest application directory partition in this particular instance. Now, if we select this folder, we can see that we have a few records here. We have the start of authority, the name server records for all of the domains in the forest, and these alias records, which contains the globally unique identifier, or the GUID, for the names of these domains. And these GUIDs is why we can use some of the newer Windows 2003 and 2008 features, like the ability to rename domains, because some clients might not be able to find the domain if it's been renamed, but DNS will know about it by referencing this GUID. So even if the name might change, the GUID here always remains the same. So if we expand our _msdcs folder, and then expand one of the subfolders here, for example, the DC folder, we've got a couple of other subcontainers. We have sites and TCP. So let's take a look under the sites folder, and we see that we have the default first site name folder. So we'll expand that, and under here we have a TCP folder. Now this default first site name container is linked with the sites that we create in Active Directory. Now this is kind of out of scope here for our DNS videos, and more of what you're going to see in our Winstructor sites and replication videos, which I would encourage you to check out if you haven't done so already. But if we quickly go and open up Active Directory sites and services, and if we expand sites, we can see our default first site name. So let's say that our winstructorlab.com domain is physically located in the US. We could right-click on this and choose to rename this site, and we'll rename it to US. Now let's go and close this console. We don't need it anymore. And we're also going to close our DNS console, as we'll need to reopen it so I can recognize our site's name change. So let's go and click on Start Administrative Tools. We'll launch the console again, and we'll expand our forward lookup zones. then our MS-DCS folder, DC, sites, and this time we have a site called US, and if we expand that and select the TCP folder, inside here we can see we have two records, one for Kerberos and another for LDAP. Effectively what's happening here is that clients in our US site, when they contact DNS in order to locate an LDAP server or a Kerberos server, DNS will look inside the US site for that client, see the service record here telling it where the server is, and in our case DNS would go back to the client and tell it, hey, if you want to find a server to answer your LDAP queries, then go and talk to DC01 because that's the LDAP server and you can do that on port 389. Now our other folder here, the TCP folder, just shows us all of the records we have here irrespective of the site. So if we had several sites here, we'd expect to see a few more records just pointing to other sites. Now under this parent MS-DCS folder, we've got three more containers here, domains, global catalog, and PDC. The domains container holds the service records for the domain controllers we have in our domain. So if we expand this, we can see we have three subcontainers which are named the same as the GUIDs of the domain controllers in our domain. Again, this GUID allows us to rename the domain and the domain controller, and DNS can still find them. So if we expand out these containers, you'll notice that in my lab here, I have three domain controllers. The first one is DC01, the machine I'm on right now. We have DC03, which is the domain controller for my London domain. And also, we have DCT01, which is my New York domain controller. So even though I'm currently logged onto the parent winstructorlab.com domain, my DNS server knows that if I need to make an LDAP query to my New York subdomain, then DCT01 is the server I need to go to. Now the next folder here is the global catalog folder, and this is what DNS uses to find domain controllers that run the global catalog service. And if we expand this out, we can see global catalogs by site, and of course again, we'd expect to see all global catalogs listed inside our TCP folder. Now finally at the bottom here we have the PDC folder, and this tells us which server holds the PDC emulator role in our domain, and since only one server can hold this role, you'll only expect to see one service record inside this folder. Now let's move on and expand our forward lookup zone for winstructorlab.com here, as we still have a few more folders that we really should talk about. Firstly, we have the sites folder, which is going to show us what sites we have configured in this domain. If we expand this and then expand our US site and select TCP, you'll notice on the right that we have three service records here for the global catalog service, Kerberos, and LDAP. So when a client that's a member of this site logs on, it's going to need to contact a domain controller that's a member of its own site so it can be authenticated to log on. So DNS here, using these service records, is able to tell our clients where a logon server is by telling the client that DC01 currently holds these roles. Now on the left next we have the TCP and UDP containers, and they hold all of the service records for services that run on either the TCP or UDP protocol, irrespective of any sites they may be in. So if we select our TCP container, you'll notice over here on the right that we have two service records for global catalog servers, since we have two domain controllers that are also global catalog servers. So when a user from this domain needs to locate objects in the London domain, DNS knows that DC03 is the server that we need to go to. Now the other two folders that we have here are the domain DNS zones folder, and this shows us all of the sites in our domain. And if I expand this out, we should see only one US site in this domain now. And we also have the forest DNS zones container, which shows us all of the sites in the forest. And since I renamed this local site to US, we should see two sites here, which is the default one and the US one. So if we drill down into the default site, in the right, we can see we have two service records here for our other two domain controllers, and of course, DC01 should be by itself in our US site. All right, so let's go back to our TCP folder. And the reason I want to come back to this folder is it has the most service records in it, and I'd like to explain what these records here are for. So the first record we have is for the global catalog service, and its purpose is to identify which servers are running the global catalog service. The Kerberos record is used for authentication purposes. We have a K-password record, which allows a user to locate a Kerberos password change server that conforms to the Kerberos change password protocol. And finally, there's LDAP, which is needed to talk to Active Directory. So let's take a closer look at one of these records here. And since we have it selected, let's use the LDAP record. Now, this LDAP record's job, as we already discussed, is to help DNS servers locate a server that's running the LDAP service. Now, over on the right, if I just expand this so we can see what's going on here, for this service, we can see that its priority is set to 0, the wait is 100, and the service listens on port 389. Now, if we double-click on this record, we can edit some of the properties if we like. So here for this domain, winstructorlab.com, we can see the service is LDAP. It's using the TCP protocol, of course, on port 389, and the host that's offering this service is DCO1. Now, any of these white fields here we can change if we like. So, for example, if you wanted to edit the priority and wait to load balance these, you could do so right here. Now, we also have a security tab here where we can use the Windows Access Control List to control permissions to this object. Now, by default, only members of the administrators, domain administrators, enterprise administrators, and enterprise domain controllers groups have full control over these objects. So, if we have to sum up what this whole MS-DCS folder is all about, it's really a single location that allows us to find servers that perform certain functions anywhere in our forest, regardless of domain. And this is really useful because let's say that I'm a traveling type person and I'm in the US, but tomorrow I'm traveling to London. Well, when I get there, I'm going to need a domain controller to log on with. This folder is what makes that all possible. Now, one final thing I want to talk about before we move on to discussing some of the other records is what we need to do if this MS_DCS folder isn't available. Now, by default, it is created when you create your first primary zone. Now, if your first DNS server has been created on some other DNS system, then this folder might not be created, so you'll have to do that manually. So to do this, we'll simply right-click on our forward lookup zones, we'll select a new zone, we'll click Next, we'll choose to leave the default at Primary Active Directory Integrated Zone, we'll click Next, then we'll select the first option here to replicate this to all DNS servers in our entire forest, we'll click Next again, and then we'll simply name the zone ms.dcs.winstructorlab.com, or whatever the name of your forest root is. Then we just click Next through the remainder of the wizard, and we're done. All right, now that we've got service records out of the way, let's take a look at the records you'd expect to see inside your forward and reverse lookup zones. So, we'll select our winstructorlab.com zone, and in the right-hand side, the first record we can see at the top here is the Start of Authority record, or SOA record. This Start of Authority record indicates the name of origin for the zone and contains the name server that's the primary source for information about the zone. It also indicates other basic properties of the zone, such as the versioning. Now, over here on the right, under the data column, we can see that it starts with a serial number of 79. Now, when we make changes to our zone, secondary DNS servers will compare their version number with this one to determine whether or not they need to update their records. So if we go and right-click here, and let's choose to add a new record. Let's just create an alias record for now. We'll call it whatever we like, and just click on OK. And now if we hit F5 to refresh our console, you should see this version number change, and our Start of Authority has now been incremented by 1. This means that our secondary zones will be able to tell that there's been a change just by looking at this number. Now also note that if we go and right-click on that record we just created and choose to delete it, and then hit F5 to refresh our console again, the deletion was recognized as another change, so our Start of Authority has again been incremented by 1. Now the next record we have here is the name server or NS resource record, and it's used to identify which DNS servers are designated as authoritative for the zone. Now here we can see that it identifies dco1.winstructorlab.com as being the name server for this zone. Now the next record is probably the most common record that you're ever going to see in DNS. It's a host or an A record. Now this simply associates the name of a host with its IP address. So the first record that DNS knows about is the IP address of itself. So on our DNS server here, we can see that the IP address is 10.32.0.2, and you'll also find we will have a second host record here that maps our host name of our server to its IP address. Now, the other default record we have here is this IPv6 or the 4A's record, which is what associates the name of a host with its IPv6 address. And since Windows 2008 has IPv6 turned on by default, you're going to see those records in here as well. So let's take a closer look at these DNS records, and firstly we'll double click on our Start of Authority record, and this will take us into the properties of the zone, directly to the Start of Authority tab. Now the first field here is the serial number that we mentioned a moment ago. This is where secondary DNS servers will compare their serial number against our primary server, and if this number is higher than theirs, a zone transfer will be performed, so the secondary server can have a current copy of the zone. Now this number will increment automatically as changes are made to this zone, or we can increment it manually if we like by simply clicking on this increment button. Now next we can see the name of the primary server, which as expected is our server DCO1, but you also might notice that our server name has this trailing dot at the end of it. Now in DNS, if you want to be technical, to have a fully qualified DNS name actually requires this trailing dot. If you'll recall when we discussed DNS resolution, that Winstructor Lab was delegated to us by the people who own the .com namespace, and the .coms was delegated to the people who manage the root. So in order to have a full DNS name, technically it must go all the way back to the parent, which is the root, and hence that's the reason for the trailing dot. Now, in most situations, we won't ever see or have to enter in this trailing dot when we ping anything or open up a web page, but DNS does use it behind the scenes. Okay, next we have the responsible person. Now, even though this doesn't look like it, this is actually an email address, except the @ symbol, which isn't a valid DNS character, has been replaced by the dot. Now, the default is set to hostmaster, but we can, of course, change this if we wish, perhaps to something like techsupport@winstructorlab.com or something like that. And again, to be complete, we also have the trailing dot after this email address. Now the refresh interval here defines how long the secondary servers will check back with this DNS server to see if there's been any changes. Any DNS servers will check the serial number that we mentioned a moment ago to see if there's been changes, and if there have been changes, it'll initiate a zone transfer and pull the records to the secondary. Now, if there are problems with performing a zone transfer, then it will retry after the interval that's specified here, which defaults to 10 minutes. Now, if the secondary server is unable to contact this server for a full day, then the secondary's copy of this zone will expire and it will no longer be used. And when the secondary server is finally able to contact this primary server later on, it'll reactivate its zone and then perform any necessary zone transfers. Now, the minimum time to live, or TTL, is set to 1 hour, and this means that when a client successfully resolves a host name using this DNS server, it'll cache the name and IP address for an hour, and then it will expire. And for the Start of Authority record itself, it's going to be kept for 1 hour. Okay, so the next thing we want to take a look at is this name server record, so we'll double click on that, and this will open up the properties for our zone directly at the Name Servers tab. Now this tab shows the name servers that are authoritative for our zone. So here we can see dco1.winstructorlab.com, that DNS server, is listed as our authoritative name server. Now, if we wanted to add in another server, we could simply click on Add and enter in the fully qualified name and IP address of the server, and then click OK, and then we're done. Now, of course, if you have any old servers in here that you want to remove, you could simply highlight the server and click Remove. Or if you need to edit any existing name servers, you can click on the Edit button. Okay, well, the next DNS record we'll look at, and definitely the most common record, is the host or A record. And a host record simply associates a host name with an IP address. Now, in my network here, we already have a few host records for each of the servers in this domain, and when we add new computers to our domain, they'll automatically have a host record created that corresponds to their IP address. But for some devices, you'll need to add one in manually. For example, I have a router on this network which isn't part of my domain, but we can still create a host record for it. So let's do that now. Let's right-click and we'll select a new host record, and I'm going to give this record a name of router. Now, as we can see, the fully qualified domain name automatically becomes router.winstructorlab.com, and what we'll need to do next is tell the record the IP address of our router, so I'm going to enter in 10.0.0.1, and you'll also note that we can create an associated pointer record which will create a record in our reverse lookup zone. Now, if you don't have a reverse lookup zone, checking this box will cause an error, as this box will attempt to create a record in your reverse lookup zone that enables reverse lookups to be performed on this host. And of course, if you don't have a reverse lookup zone, it will of course throw up an error. Now, if you do have a reverse lookup zone, then you can check this box. And the final checkbox here to allow any authenticated user to update DNS records with the same owner name usually won't be checked for security reasons. So we're going to leave everything as you see it. We'll click Add Host. We can see our record was successfully created. So we'll click OK, and then we'll click Done. All right, at the bottom here, we can see our new host record. And now when we go to ping our router, we're able to do this by name. So let's go and open up a command prompt. And I'm going to type in ping router and hit enter. And as long as we could reach the router, it'll respond to our ping, and the hostname router is now mapped to the correct IP address. Now, the next common type of record we should look at is the CNAME or alias record, and this type of record is used to provide, as the name suggests, an alias for another host name. So let's say that our server DCO2, which is our secondary DNS server we created in an earlier video, also happens to be our web server or an FTP server, for example. Now, when people try to contact a web server, they expect to visit www, whatever the name of the domain is, .com. And that's a universal thing. People have it ingrained in their minds that a web server always begins with those three letters, www. Well, if we're running IIS on our server DCO2, then without an alias, users would have to type in dco2.winstructorlab.com into Internet Explorer to get to our website. And that's certainly not what they'll be expecting to do. They'll be expecting to type in www.winstructorlab.com. So to fix this, what we need to do is to provide an alias of www to our server. So to do that, we'll right-click and we'll choose to create a new alias. And because we want people to log into our web server using www and not DCO2, we'll need to type www into our alias name field. Now, as you can see, this populates our fully qualified domain name to www.winstructorlab.com, exactly what our users will be expecting to type. So in our host field here, we'll need to enter in the server on which we're hosting our website. So we could either type it in manually, or we can click Browse, and we'll navigate through our server, and then our forward lookup zones, and then our domain. And we'll scroll down and locate our host record for DCO2. So we'll select that, we'll click on OK, and that'll populate our fully qualified domain name field here of the target host. So we'll click on OK. And now if we go back to our command prompt and we'll try to ping www.winstructorlab.com and we'll hit enter, we can see that it comes back with DCO2 being the real host that our web server now points to. Let's suppose we also wanted people to be able to use FTP on this same server, DCO2, or we could simply add in another alias. So we'll go back to our DNS console and we'll right-click, we'll create a new alias. We'll enter FTP as the alias name, and then we'll click Browse again, and we'll go and locate our server, which is DCO2. We'll click OK and OK again. Now we'll go back to our command prompt, and this time we'll try to ping our server ftp.winstructorlab.com, and again, the reply is coming from DCO2. Now, a couple of points I should make about these aliases. You can't have more than one alias of the same name. So in other words, we can't have an alias of www pointing to DCO2 and then add another alias of www pointing to DCO1. But we can add more than one different alias to a host, as you just saw, we've created one for www and for FTP, both pointing to the same machine, DCO2. But since names are unique, we can't have two hosts using the name FTP. All right, well, let's move on. The next type of record we have up here is the MX record, and an MX record is a mail exchanger record, and as you've probably guessed, it's used for identifying email servers. So when you send an email to, say, tim@winstructorlab.com, you've told your email client that you want to send an email to someone who has an account named Tim on the server in the winstructorlab.com domain. What you haven't told your email program is what server Tim's account lives on. With web and FTP servers, there's an unwritten rule that says web servers and FTP servers should start with a www or an FTP. Whilst this isn't written in stone, of course, when you point your browser to a website, you just simply expect to type in www.something or other. With email servers, there's no such rule. An MX record is what tells DNS what server email needs to be sent to. But before we go and create an MX record, let's quickly go and add in another host record for our mail server. So we'll enter in a host name of mail1, and I'm just going to give this an IP address of 10.32.0.81, and we'll click on add host, and then OK, and then we'll click done. Now, I will point out that this host doesn't actually exist on my network, but it doesn't matter for the purposes of demonstrating how it works. It doesn't care whether it exists or not. Okay, so now that we have our host record created that points to our fictitious mail server, we'll need to create an MX record. So to create an MX record, we'll again right-click. We'll choose a new mail exchanger or MX record. In the first field up here, we'll need to add a host or a child domain. Now, in our case, as we want our mail to be in the winstructorlab.com domain, we can leave this field blank. Now we'll need to enter in the fully qualified domain name of an email server, so we'll click on Browse. We'll navigate through our server here, forward lookup zones, and then our domain winstructorlab.com, and we'll scroll down, and we'll locate our mail1 host, and we'll select that and click on OK, and that's going to populate the fully qualified domain name of mail1.winstructorlab.com. Now, in the priority field here, you can see that this defaults to a value of 10. With this server being our only mail server at this point, this box has no effect on anything. However, when we have multiple servers, that's when this priority field comes into play. The way priority works is that the lower the number, the higher the priority a host will have. So for now, let's just leave it at 10, and we'll click on OK. And here we can see that our MX record has been created. So let's go and add in a second mail server. We'll right-click, we'll add a new host again. I'm going to call this host mail2, and we'll give it an IP address of 10.32.0.82 this time. And we'll click on add host, OK, and then done. Now let's go and create a second MX record for our second mail server, mail2. So we'll right-click, we'll choose a new MX record. As before, we'll leave the first field blank. We'll click Browse, and we'll navigate through our server, forward lookup zones, our domain, winstructorlab.com. We'll scroll down and select mail2. We'll click on OK. And again, that's populated our fully qualified domain name of mail2.winstructorlab.com. And in the priority field here, we again have this default value of 10. So let's change this to a higher value, say 100, and we'll click on OK. Now what we have here is two host records pointing to our email servers and our two MX records that tell DNS what servers on our network are actually running as mail servers. So now, because we have two email servers, mail1 will be given the higher priority as it has a lower priority number. So mail is always going to be directed to the host called mail1. This in effect means that unless my first mail server, mail1, is down, mail2 should never receive any email. Now, we could, if we wanted to, add in a third MX record and give it the same priority as one of our other servers. So let's do that. Let's right-click. We'll add in a new host. We'll call this mail3, and we'll give it an IP address of 10.32.0.83. We'll click add host. OK, and then done. And now we'll go and add another MX record. So we'll right click, we'll add a new MX record. As before, we'll leave the first field blank. We'll click Browse. Go to our server here, DCO1, forward lookup zones, our domain. We'll scroll down and select Mail3 and click OK. And in our priority field again, of course, it defaults to 10. So for Mail3 this time, we'll leave it at 10. We'll just click on OK. All right, what we have here now is 3 MX records overall. One of them has a priority of 100, and the other 2 both have priorities of 10. Now, we already know that Mail2 with its priority of 100 is the last server to ever receive email. But what about the other 2? Mail1 and Mail3 both have the same priority of 10. So which one wins? Well, actually neither is going to win, because this is the sort of configuration you'd use when configuring multiple mail servers to share the load. Both servers will receive an equal amount of email. And only if both Mail1 and Mail3 are down will Mail2 ever receive any email. In fact, at this point, Mail2 is really just a redundant machine sitting there on the network as backup, just in case Mail1 and Mail3 are down. Now, one thing that I should point out is that some spammers like to try to connect to servers in your company that have the lowest priority, as it's often less likely to be met by your spam filters. Often in many organizations, people will configure an MX record with the highest priority to be a spam filter server, so that way mail gets sent to the spam filter first before being forwarded to your real mail server. And that's good, sending it to a spam filter first, but spammers unfortunately aren't stupid, so they know that sending mail to your server with the lowest priority, or in other words, the highest number, is likely to be configured to go directly to your mail server. So I'd recommend that if you have 2 mail servers, for example, then configure your 2 MX records to forward mail to your spam filters first, and then configure the spam filters to forward that mail to your real mail servers. That way, regardless of which server actually receives the email, it's been filtered for spam first. All right, well, let's move on and take a look at some of the other records that we have in DNS. So let's right-click, and we'll select Other New Records. And as you can see by this list here, there are quite a few. Now, some of these we've already talked about in this video, and most of these you probably won't ever use. Some of them are relatively new, and others are largely experimental. But for completeness, let's go and take a look at all of them. First one we have here is the AFS database record, or Andrew File System Database, and it's an experimental record for identifying AFS cell database servers, and it maps a domain name to the AFS server. In the case of DCE, it maps the domain name of a cell. Now, we would need to enter in a host and the path to the AFS server. Now, if we select the subtype option, we can enter in the value of 1 or 2, and it defaults to 1, which is an AFS version 3.0 server. And if we type the value of 2 into this field, it identifies a DCE authenticated server. Now, the next one, the alias we've already looked at, the ATM address, maps a domain name to an ATM address, and this ATM address can be specified either in E.164 format, which is decimal, or an NSAP hexadecimal format. Now, we've already talked about our host records. We also have a hinfo record, which provides a brief description of the hardware and software used by the specified host. Now, currently, no system really makes a lot of use of hinfo records, but if you look up RFC 1700, you can get a list of the format needed for this record. And here you can see we have 3 fields. The first field is the host field, which in our case we can enter in DCO1 here. Next, we have a CPU type, and in some implementations this is often referred to as the hardware type. And here we could enter in the name of up to 40 characters, which must be uppercase characters, digits, and the 2 characters hyphen and slash. Now, the number must start with a letter and end with a letter or a digit. Now, next we have the operating system field, sometimes called the software field in some implementations of DNS, and this identifies the operating system that's used by this host and follows the same naming conventions as the CPU field. So in keeping in line with the RFC 1700, a valid CPU name would be something like PC Intel 800 MHz. And a valid operating system name would be Win32. But again, it's unlikely that you'll ever need to use the hinfo resource record. Now, another type of experimental resource record is the ISDN one, which maps a domain name to an ISDN phone number. So here we'd enter in the ISDN phone numbers or direct dial-in number, and this should be an international telephone numbering standard. So for example, the value of 1 would indicate USA, 212 for Manhattan, New York area code, and then followed by the rest of the number. Now the ISDN subaddress is an optional string of hexadecimal numbers. We've already talked about the next record, which is the mail exchanger record. Now the mail group, mailbox info, and if we scroll down a little bit, the rename mailbox records are generally not used, as most internet-based email servers only supports the MX record that we've already talked about. Now this mail group record is used to specify mail group members, and there must be one mail group record per member. Each member's mailbox must be identical to a valid mailbox record. The mailbox record maps a mailbox to a host. Now that host must be the same as a valid A record already defined in the same zone. Now the mailbox information record specifies the mailbox of the responsible person and optionally a mailbox for errors for this mailbox or list. Now each mailbox must be the same as a valid mailbox record that already exists in the zone. And the other one, which was the rename mailbox record, obviously specifies a rename mailbox, and this MR record can be used as a forwarding entry for a user that's moved to a different mailbox. Now the next domain, the public key, and if we scroll down a bit, the signature record are all part of DNSSEC or DNS security, which is a secure DNS protocol designed to prevent spoofing and protect data integrity. The DNS implementation uses the familiar public-private key system where the administrator for that site generates a key pair for the secure domain. The private key is generally kept on the domain's primary master name server, and the public key is published in the domain in a key record. The administrator signs the domain's data record to verify its authenticity and then adds a signature record which contains the signature for each domain record. The administrator submits this public key to the administrator of the domain's parent with proof that he is the administrator of that domain. The parent domain's administrator signs the domain's public key and then returns it. Well, next we have the responsible person record, and this specifies the mailbox of the responsible person for the host. So whereas a start of authority record defines the responsible person for an entire zone, this responsible person record makes it possible to identify the responsible person for individual host names that are created within that zone. Now, unlike the other DNS email addresses we've already seen in this video, specifically the hostmaster default address, when you need to specify a mailbox here, again, you'll just need to replace the email address's @ symbol with a dot. Now you can also add in a text record to the responsible person record, and this is optional but can be used to provide contact information such as the person's telephone number. Now next we have a route through record, which specifies an intermediate host that provides routing to the domain name of the record, and this can be used by computers that are not directly connected to the internet or a wide area network. In here we can see we also have a preference value, and this is used to set priority if multiple intermediate routing hosts are specified. As with MX records, the lower values are tried first. Now for each route through a specified host, you will need to have a host record or an A record for the current zone. Now service records we've already talked about. We also have a text record here, which allows you to associate any arbitrary text with a host name. Some earlier implementations of the bind command do not support the text record, but do support a bogus record type called uinfo that basically does the same thing. And they're used to hold general information about a domain name, such as who's hosting it, contact person, phone numbers, and things like that. So text records are informational for people only, and they're not required for any standard DNS functions. Now you can also have multiple text records for a single host name, so simply just enter in some text and the host name, and then just click on OK. Now we have the well-known services record, which describes the well-known TCP/IP services supported by a particular protocol on a particular IP address. Well-known service records provide TCP and UDP availability information for TCP/IP servers. So if a server supports both TCP and UDP for a well-known service, or if the server has multiple IP addresses that support a service, then you'll need multiple well-known services records. So if you want to know more about the well-known service record, you can go and check out RFC 1035. Now finally we have the X25 record, which are used to map a domain name to a public switch data network address number. And any numbers used with this record should follow the X121 International Numbering Plan. So in this video, we've talked in detail about DNS records, and as you've seen, there are a lot of different types of DNS records available, although in 99% of cases, you'll be sticking with host records, aliases, and MX records. So as long as you understand those three, you'll be fine, and it'll cover almost everything that you need to know about DNS. We hope you've enjoyed this video, and would like to thank you for supporting Winstructor.